Hello guys. So the important questions. All the points of the curve is this, at which the tangent is parallel to the x-axis, and we will prove this. All the points of the curve lie on the parabola. Parabola means y square equals to 4ax. So all points should lie on the parabola if on this parabola tangent is parallel to x-axis. So let us consider the points. Let we consider a point x1 y1, and according to condition tangent parallel to x-axis, it means the slope of tangent is, because it forms angle 0 with x-axis, so slope is tan theta, so tan 0 is 0. That means dy over dx at given point should be 0. For this we have to collect dy over dx, and we have the function is this. So we differentiate it. Y equals to 4a x plus a into sine x over a. Now on differentiation we get dy over dx, 4a common, differentiation of x is 1 plus a into differentiation of sine is cos, and differentiation of x over a is 1 over a. So 1 over a and a is cancelled out, so we have this. Now we put it 0, so dy over dx, that is 4a 1 plus cos x over a. So right now we apply this condition, means 4a 1 plus cos x over a equals to 0. It means cos x over a equals to -1. Now according to question we have sin x over a, so we convert it in form of sine. So we know this, the formula by trigo, sin x over a is under root 1 minus cos square. So we put this value, it is 1 minus -1 square, so we get 1 minus 1, or you can say 0. So the value of sin x over a is 0. So we have equation of curve y equals to 4a x plus a sine x over a, and the point of contact is x1 y1. So if this point lie on this parabola, so the equation of this curve should be satisfied with this point. That means it is y1 4a x1 a sin x1 over a. As we know, sin x over a is 0. It means when we put it in this expression, we get y1 square equals to 4a x1. So this is the equation of parabola. So y1 square equals to 4a x1. It means the points x1 y1 lies on the parabola y square equals to 4ax. Hello guys. So we are taking the question of tangent normal. If a straight line x cos alpha plus y sin alpha equals to p, this touches the ellipse x square over a square plus y square over b square equals to 1. So if it is a tangent, this equation is the tangent of this ellipse, then prove that p square equals to a square cos square alpha plus b square sin square alpha. So we have to prove this. If this line touches this ellipse, so it is a tangent to this. So right now we have ellipse, this one, and this line is x cos alpha plus y sin alpha equals to p, and let us consider this is a point x1 y1, and this is ellipse. So right now let the point p is x1 y1. So according to coordinate geometry, the equation of tangent at x1 y1 on this curve will be x1 over a square plus y1 over b square equals to 1. So this is the equation of tangent, and according to question we have this line as a tangent. So this line or this line, these should be identical. So the given tangent line, it is x cos alpha plus y sin alpha equals to p. So both are identical. So both lines are same. Equations 1 and 2 are identical. Means both are tangent, the equation of tangent. If these are identical, so we can compare their coefficients. So it will be x1 over a square, this is a multiple of x, and there is cos alpha. Same way, so y1 over b square over sin alpha, and it is 1 over p. This is comparing So right now we want the result. This is the ratio of x over a. So we will collect the values of x1 over a from this. So we have x1 over a square over cos alpha, y1 over b square sin alpha equals to 1 over p. So x1 over a is a cos alpha, or you can say y1 over b sin alpha equals to 1 over p. So we will collect two relations. So x1 over a is a cos alpha over p. This is the first relation, and from this we get y1 over b. It is b sin alpha over p. So on squaring and adding, these two relations, so we get x1 square over a square, and left hand side of this is y1 square over b square. This is a square cos square alpha over p square, and b square sin square alpha over p square, and this is the LCM p square. So it is a square cos square alpha plus b square sin square alpha is x1 square over a square, y1 square over b square. So right now if x1 y1, so this point x1 y1 lie on this ellipse, so this point should satisfy the equation of ellipse. That means point P, that is x1 y1, lies on ellipse. So the equation x1 square over a square plus y1 square over b square is 1 when you put this point in the equation of ellipse. So this is the third equation. Right now we compare this result with this, and this is the value of is 1. So we get a square cos square alpha plus b square sin square alpha over p square equals to x1 square over a square plus y1 square over b square, and the value of this is 1. So you can place this. Now you can compare right now this value. So a square cos square alpha plus b square sin square alpha over p square equals to 1. So right now p square comes on right hand side, means a square cos square alpha plus b square sin square alpha equals to p square. So this is the required expression. So hence proved. Find the coordinates of the points on the curve y equals to x square plus 3x plus 4. Condition: the tangents at which pass through the origin. So we want to collect the coordinates of the points on the curve. Curve equation is this. So the tangent at these points passes through the origin. That means you have a curve, and this is a point P x1 y1, and when we draw a tangent on this point at the curve, and this tangent passes through 0 0, so we want to collect this point. So let the point P be x1 y1. Now we have the equation of the curve. Y equals to x square plus 3x plus 4. So on differentiation, we get 2x plus 3. So the slope of tangent, it will be dy over dx at given point x1 y1. It means we have the relation 2x1 plus 3. So this is the slope of the tangent, and this tangent passes through 0 0. So this is a point and this is the slope. If we have point and slope, then we will use point slope form. So using point slope form, that is y minus y1 mt x minus x1. So point is this and slope is this, so we will use this. So we get y minus y1, m is 2x1 plus 3, and this is x minus x1. So this is the equation of tangent, and this tangent passes through 0 0. That tangent passes through 0 comma 0, and we have the equation of tangent is y minus y1 2x1 plus 3 and x minus x1. So when this passes through this, then this point satisfy the equation of tangent. So we put xy as 0 0. That means 0 minus y1 2x1 plus 3, and this is 0 minus x1. So when you cancel minus minus, you get y1 equals to x1 into 2x1 plus 3. So this is the value of y1, or you can say y1 equals to 2x1 square plus 3x1. If the point x1 y1 lie on the curve, so again it satisfy the equation of curve, that is y equals to x square plus 3x plus 4. That means point P so we can write y1 equals to x1 square plus 3x1 plus 4. So again this is the value of y1 and this is the value of y1. So we can equate these two. So from 1 and 2. Now 2x1 square plus 3x1 equals to x1 square plus 3x1 plus 4. So cancel out 3x1 3x1 and this comes here, and you get x1 square equals to 4. That means x1 equals to plus minus 2. Now we have x1 is plus minus 2 and y1 is x1 square plus 3x1 plus 4. So when you take x is 2, positive 2, then y1 will be 2 square plus 3 into 2 plus 4. It is 6, 4, 10 and this is 14. So point will be x1 y1, or you can say 2 comma 14. When x1 is minus 2, then y1 will be minus 2 square plus 3 into minus 2 plus 4. So you get it is 4 minus 6 plus 4, it is 8 minus 6, it is 2. That means point will be minus 2, 2. So these are the answers. Required points are 2 comma 14 and minus 2 comma 2.